Despite some of the shady practices of big tech, the reality is that the quality of their engineers and the products they are building is higher than what most companies can achieve. And Google is probably the clearest example of that. Sure, you first have to set your ethics aside because, at the end of the day, all these tech companies have profit as the ultimate goal. Then, you also have to ignore the hundreds of companies and products they killed over the years, but once you get over that, you'll realize that Google managed to build some pretty amazing tools for us developers. Golang, Kubernetes, TensorFlow, gRPC, Protobufs, Dart, Flutter, Firebase, and many others are all products built for developers who are quietly powering half of the modern developer stack. So, when a prolific engineer posts about 21 lessons from 14 years at Google, we should talk about it because it's guaranteed we'll learn a few things about how real engineering at scale actually works.
It's the Monday Morning Review.
Addy Osmani is an established figure in the front-end world. He's been at Google for over a decade, working on Chrome, developer experience, and web performance. He is also the author of one of the first JavaScript books I read back when I started front-end development and jQuery was still a thing. We'll not go through all 21 lessons in this video, because I know you guys are watching my videos during work time and probably a Teams meeting is right around the corner. Instead, I'll focus only on the key takeaways which will actually turn you into a better software developer that can also tackle the business side of things. The main lesson is one that took me almost 10 years to learn, and it is one of the hardest ones to accept even to this day. The best engineers don't chase shiny tech, they chase user problems. The people who make a real difference aren't the ones arguing about which JavaScript library is slightly faster. In order to bring real value to a product, you need to understand the customer pain points, what users struggle, and think hard about the actual problem you are trying to solve. The answer to the question, what is the best tech stack to build a product, is always the tech stack you know best. In other words, if you want to build a real product for real people, tech choices can become unnecessary noise. If your experience is in Java and React, stick to that because real impact comes from fixing what actually matters, not what's fun. This is also outlined in the article in another rule, stating that novelty is a loan you repay in outages, hiring, and cognitive overhead. In other words, every time you pick an unusual framework, roll your own deployment system, or invent a new way to structure your folders, you're taking on technical debt. And this leads nicely into another general rule everybody is aware of, but nobody actually follows. You should ship early and ship ugly. There is this joke I make from time to time that all my million-dollar ideas failed because of the complexity of a perfect registration flow. Of course, these are the ideas which pass the choose a name and logo phase, which is usually even more complicated in my experience. In Addy Osmani words, the quest for perfection is paralyzing. Engineers love to overthink. We'll spend weeks debating architecture for a feature no one's even sure is needed, but the hard truth is that real clarity only shows up after you ship and see customers trying to figure out the process you envisioned. Of course, you can clean up bad code, even though we all know we'll never actually get back to doing it. But you can't fix what doesn't exist, and the only guaranteed path to failure is to never go all the way. The next rule, however, is probably the highlight of the article. Clarity is seniority, and cleverness is overhead. The instinct to write clever code is almost universal among engineers, but the smartest man in the room is usually able to explain difficult concepts in plain, simple words. And the best engineers write code the same way. Good code is clear enough that someone new can read it, follow it, and debug it without needing a 2-hour walkthrough or a Slack history deep dive. Adding in code and complexity is really easy, especially in the AI slop era. This is actually the biggest problem with Vibe-generated code in my experience. AI code is usually filled with a huge amount of unnecessary noise, which is just technical debt and cognitive load you'll have to tackle later. And this is why we are starting to see articles like this one, where people are finding out that the time needed to clean up a Vibe-coded implementation is actually more time-consuming than it would have taken to write the thing properly in the first place. Cleaning up code and removing complexity without breaking anything is what's really difficult. And this leads us to another great rule. The best code is the code you never had to write. Nobody gets promoted for deleting code, even though deletion often improves a system more than addition. Every line of code you don't write is a line you never have to debug, maintain, or explain. So, weirdly enough, at times, deleting unnecessary work or processes is almost always more impactful than doing necessary work faster. And here's your trivia for the day.
Awesome trivia in 10 seconds.
Removing parts of the process at the right time can actually influence the world for the better. In the 1960s, for instance, the go-to statement was accepted by the software world as a fundamental tool, and languages like assembly, Fortran, COBOL, and BASIC relied on it. Programs were written as control flow mazes because machines executed jumps efficiently and humans were expected to adapt. However, Dijkstra questioned it directly and published a short letter called Go to Statement Considered Harmful. He stated that programming should enable humans to reason about machine behavior and unrestricted jumps destroy the human ability to reason about program state. As a result, structured programming emerged and we can all now enjoy a life where we have one less thing to worry about. But this wouldn't be a coding best practices video if we didn't address the elephant in the room.
Holy shit, is that a fucking elephant?
The famous computer scientist Donald Knuth stated that premature optimization is the root of all evil, but, to be fair, the same can be said about premature abstraction. This goes back to the earlier point about cleverness for the sake of cleverness when writing software. For a bit of context, my background is in Java Enterprise development, so let me tell you, I know a thing or two about unnecessary abstraction. Back when I started programming, the Gang of Four's design patterns book was pretty much a must-read, and, while interesting, it quietly trained an entire generation to see every problem as a chance to introduce an interface, a factory, an abstract factory, and then another factory just in case. Every abstraction is a bet that you won't need to understand what's underneath. This is a really good quote because there is only so much you can avoid until the abstraction leaks, breaks, or becomes a bottleneck. So you should always learn and understand the basics and the lower level stuff regardless of the frameworks or abstractions you are using. And this is why vibe coding will cause you a lot of trouble if you don't understand what's actually happening underneath. The last thing I'd like to address before wrapping things up is something not that popular in an industry where working 80-hour weeks and spending sleepless nights grinding at your startup are somehow still worn as badges of honor. But at the end of the day, work-life balance is more important than we'd like to acknowledge. The constant hassle and grind are both toxic and unsustainable in the long run. The truth is that most good software comes from people who have the space to think, test, simplify and iterate. And the space is full of success stories where companies chose sustainability over burnout and still built incredible products. Of course, expertise comes from deliberate practice and pushing slightly beyond your current skill. But this has to be a long-term sustainable habit in order to actually compound and produce real results. It's all a marathon, not a sprint, even though all the AI hype might make you think otherwise these days. So, the bottom line is actually straightforward and could probably be summed up as be smart, stay stupid. Don't try to impress anyone with clever implementations or abstractions, remove complexity when possible, and just assume that the person in charge of maintaining your code, which is probably your future self, is tired, under pressure, and doesn't need puzzles, riddles, or architectural flexing. So just keep it simple and don't forget to learn a new thing from time to time. If you liked this video, you should probably check one of these ones next. Please don't forget to aggressively smash all the buttons YouTube is throwing at you these days. And until next time, thank you for watching.